All right, so topic 1.5, we're looking at the formula for power. So the rate of doing work or transforming energy is the definition of power. So you'll see here that there are two possible uses of this formula. So if we're using our watts, which is technically, power is watts, which is technically joules per second. So the W would represent joules, which is work, and then our T is time in seconds. You could also look at it as energy. It just depends on how the question is worded. So if we're looking at the first question, it says 2 lamps emit the same quantity of light. One uses 17 watts and the other uses 60 watts. Calculate the electrical energy used by each bulb in 1 hour. So what you have to notice here is that you have to convert first your time into seconds. So 60 minutes in an hour multiplied by 60 seconds per minute. So you get your 2.2 times 10 to the 5 joules. And then that's going to be your energy. So then you get your number from there. So again, your power is 17 joules per second and your time is 3,600 seconds. And then of course, turning it into 2 significant digits from the equation, you're going to get 6.1 times 10 to the 4 joules. Okay, so question number 2. Again, we're looking at a question here where they're comparing refrigerators. So one's at 700 watts and the other is at 500. So again, for these questions, I'll show the answer and of course, pause the video at any time just to copy it down for yourself. So we're solving for energy. So when we're looking at our equation, we rearrange it. So we take our power in joules per second, so 700, multiply it by our time in seconds. Again, you have to convert the hours into seconds to give you 1.5 times 10 to the 7 joules. Question B basically asks which one would be more environmentally friendly. So again, when you compare the two, you look at the second one that only uses 500 watts, and that is going to require less energy in order to do 6 hours of work. So another formula for calculating power, we're taking our voltage and our currents. So again, if you look at the unit cancellation up top, this is how you get your joules per second. Let's focus there. Okay, so what is the current through a 400 watt appliance when connected to a 120 volt power line? So again, looking at your formula, solving for I, you're going to get your amps. So with sig dig's 3.3 amps. And in the second question, it says, what is the amount of power needed by an electrical device that has a current of 11 amps and a resistance of 7.2 ohms? So again, looking at our formula, we get 871 watts. So do practice problems 389, 42 to 44. Quickly show those. And of course, email me for any of those questions that you may have. All right, so looking at energy in terms of kilowatt hours, so E equals PT, and again, we're looking at kilowatt hours, which is the symbol that you often see when you're looking at appliances. So again, where you live and the demand for electricity determines the cost per kilowatt hour consumed in your home. It also depends on the company that you use. They'll always give you the price in kilowatt hours. So some companies have an initial rate plus everything over that. So that's how I'm billed. They give you a flat fee for the service, and then they charge you for everything on top of that. So again, I'll just quickly show the examples. This one has 9 cents per kilowatt hour. And if we're using it for 1 times 10 to the 3 watts for 5 hours, what would our cost be? So we find that we get 5 kilowatt hours, and at 9 cents for every kilowatt hour, we would be charged 45 cents to use that appliance for 5 hours. So if a 600 watt block heater is left on for 14 hours, basically what is our cost? And we're assuming again that it's 9 cents per kilowatt hour. So looking at our formula, we get 8.4 kilowatt hours. At 9 cents per kilowatt hour, we get a total of 76 cents. Okay, so you sand your hardwood floors with a 13 amp drum sander, and we're gonna have it at 120 volts for 2 hours. Basically how much energy is used, assuming again it's 9 cents per kilowatt hour. So we have all of our variables and our information written down the side. Okay, so we take our 13 amps, multiply it by 120 volts, which is going to give us 1,560 watts. Convert this, or multiply it by our 2 hours to get our 3.12 kilowatt hours. And at 9 cents, it would cost 28 cents to use that drum sander for 2 hours. So what's the cost of baking a cake, right? And of course, the question is going to depend on the actual appliances you're using. But let's say it's 40 amps and a 220 volt circuit. Okay, and we're going to pretend that we cook our cake or bake our cake for 55 minutes. So again, find our power, find our kilowatt hours, and then figure out our price. So 73 cents to bake that cake, assuming we're baking it for 45 minutes, or 55 minutes. Okay, page 292, 45 to 46. Again, you can pause this or email me to clarify or confirm your answers. So again, sometimes it's not always cost. In Alberta, 75% of electricity comes from coal-fired generating stations. And again, there's some problems with this, right? So some of the benefits is cheaper. It's more affordable, very abundant in Alberta. It's reliable. And one of the reasons why it's so reliable is because of the fact that it's been around for so many years, that the technology is quite advanced, as well as safety has been worked on for many, many, many years to make sure it's quite safe. What are the problems? Well, number one, carbon dioxide emissions. Number two is the destruction that mining causes on the environment, as well as the danger that it is to the workers in those mines. The waste products, not only do we get carbon monoxide and dioxide, we get mercury, we get sulfates, or sulfur oxide, sorry, selenium, arsenic, different things that are definitely not good for us. So let's look at some different ways that we get energy. So electrical power, okay, we have a proportion in terms of the amount of heat produced. So if we reduce the current, we can reduce the power that's lost in an electrical transmitter. So power companies reduce the current by increasing the voltage at which the electricity is emitted. So it's an indirect proportion relationship. You can see here. Let's see if that zooms in. Yeah, so the main source of power loss in electrical energy distribution is heat produced. So for example, when you're thinking about an incandescent light bulb, so how can the voltage be changed? So transformers change this, and it's a device that transforms the AC, so the alternating voltage of one circuit, into a different AC voltage for another circuit using separate coils of wire. So again, here's our picture of our basic transformer, and you see your primary coils and your secondary coils, which again is going to differentiate the types of transformers you have, either it's stepping up or stepping down. And we'll get to that. So describe how the transformer works. So we use page 397 and 399 for that question. And now let's look at some equations. So as I said before, depending on the coils, you're going to be stepping up or stepping down. So the number of loops on the secondary coil compared to the primary is how you consider if things are being stepped up or stepped down. So for example, if the secondary coil has 2 times as many loops as the primary coil, the output voltage of the secondary coil is double that of the primary. So again, 2 times, double. So that's a direct relationship. If the secondary coil is half as many loops as the primary coil, the output voltage of the secondary coil again is half. So it is directly proportional. What you have to be careful of is how it's worded. If they're referring the secondary to the primary, then it's direct. Remember, if they are talking about the primary and they're asking about the secondary, then you'd have to go backwards to solve for that. So that's where you would just have to be careful. So here's your formula. So your number of loops in your primary over your number of loops in your secondary is equal to the voltage in your primary over the voltage in your secondary. So as I said, if we're instead comparing secondary to primary, we'd have to flip the whole thing. So again, it would be the inverse relationship if you're solving for the opposite one. All right, so here's some examples for this. So a transformer is used to convert 1.2 times 10 to the 2 volts to 1.5 times 10 to the 4 volts. So notice how we go to a higher voltage. So that would mean stepping up because it's increased. Okay, so again, rearranging our equation to solve for our number of coils in our secondary. So we would take our equation and rearrange it to get this. So again, just paused, copy as needed. And you're gonna notice it's 3,000 turns, which essentially means 3,000 coils. So how many times does it go around? In this case, again, our initial is 240 volts, and then it goes up to 12,000 volts. So that means it's stepping up. So here are our initial pieces of information given to the question. Here is our rearranged equation. So it goes from 6,200 or up to 6,250 turns or coils. Remember, if you know it's stepping up, you should compare your final answer to your initial and did it in fact go up. So yes, 125 is lower than 6,250. Okay, that is topic 1.5.